Right, so we've got a circle here with two lines drawn in it. Let's read what we've got. Okay, centre O, radius 5, write down the Cartesian. Right, so write down one mark, dead easy. X minus 0 squared plus y minus 0 squared equals 5 squared. That'll do. You could work it out as 25, but I think that's probably better. The points P and Q lie on this. I'm going to just label what they are: 3 comma minus 4 and minus 3 comma minus 4. Fair enough. Show that the tangent to C at Q has that equation. So we find the equation of this. Okay. Now we need to find the equation, the gradient of this, and then we're in business. And it's just a straightforward C1 question. Now the gradient of this we could do in a couple of ways. The way I'm going to do it is to use the fact that the tangent meets the gradient at right angles, and the gradient of what I've just drawn there, well, from here to here it goes 3 across and 4 down, so the gradient is minus 4/3. So the gradient of the tangent is 3/4. So we're looking for this to be y equals gradient x plus c. Chuck in the coordinates 3 comma minus 4 gives us this. Minus 4 equals 3/4 x plus c, so 9/4. Add that over to the other side, we get c equals minus 16/4 minus another 9/4 minus 25/4, I think. So putting that back into the original and multiplying everything by 4, we get 4y equals 3x minus 25. And so you can see that we get, by rearranging that, we get 3x minus 4y equals 25 as required. So that's part B. Now part C says show to 3 decimal places angle P O. Oh no, that's not it. Do it in black then. P O Q. That angle there is 1.287. Okay, that looks pretty straightforward. We've got here, it's symmetrical. You can see that by looking at the coordinates, so you can justify the fact that it's symmetrical, meaning we only really have to find this angle here, and then double it. And this angle here that's 3 and that's minus 4, so it's the inverse tangent of 3/4. Inverse tangent of 3/4, and then we double it. So theta, we're going to call it theta. Theta equals the inverse, or twice the inverse tangent of 3/4, and that's the working out that we're looking for. That gives us 1.287 radians. Again, as required. Now part D. The tangent to C at P, I wonder where P was coming in, tangent to C at P and Q intersect at R. Show that the shaded area, oh cracky, you can hardly see it anymore, the shaded area is whatever they're saying it is. So what I want to do is, sorry, I'm just trying to move things but it doesn't work. So we need to find what R is. Now we've already found the equation of the straight line here. So when x is 0, we get y equals minus 25/4. So R is 0 comma minus 25/4. That's by substituting x equals 0 into this and doing a bit of rearranging. So again, we're going to double. We're going to use the fact that it's symmetrical. We've got here a triangle. It's a right angle triangle. I'm running out of colours here. But we've got a right angle triangle here. We know it's a right angle triangle because it's a tangent meeting a normal. We know the radius is 5, and the distance between well, this length here basically is what I'm talking about. This length here is 3 squared and whatever that the difference is between those squared. So we get 9 and from 16 over 4 to 25 over 4 is 9 over 4, square that, we get 81 over 16. So 9 plus 81 over 16. Basically what we've got here is this triangle here. That's 5 because it's the radius of the circle. This is, and I've forgotten what I just said now, but it's 9 plus 9 over 4. Yeah, so I think this is 225 over 16 square rooted, which is 15 over 4. As that length there. So the area of the triangle is half base times height. Area equals half of 5 times 15 over 4, which is half of 75 over 4, 75 over 8. And then the area of the sector, if we subtract that, so the sector of the circle, which is this bit here, so the sector of the circle, we know that this angle here is 0.6, basically half of the thing here. I don't know why I'm doing it all in halves, but 0.6435. 0.6435. So we want the area of that, and the area of that equals half r squared theta, which is half r squared times the angle 0.6435, and that gives us, crikey, don't know, 8.0437 or something like that. And now what we need to do is we need to take the triangle and subtract the sector, and that will give us half the area we're looking for, so we need to double it. So the triangle subtract half the sector. I'm now going to go into a calculator. So we want triangle minus sector equals one bit of the shaded, twice that will give us the whole bit that we're looking for, and that is 2.66.